There are plenty of videos on YouTube showing the construction of mobile bases for power equipment. Seems like every time I look at one, though, I see something new or something interesting. Sometimes I see something I'd like to copy. Maybe I can show somebody something they'd like to copy among all these other boring details. Here's my rough drawing. I need a base inclusive 15 7/8 by 16 7/8. I'm going to cut a notch out of the short stringer, the 15 7/8, to interlock with the long stringer. Leave the corners open, so I've cut these exactly to the lengths indicated. I've got pieces marked for a cut. I'm trying to turn this so it shows right here, all four corners, so that when that notch comes out I can lay those in there, place for a corner bead, do some beveling for welding on the bottom. A little bit easier, I think, than trying to do 45s, and I think it works out a little better. I will drill and tap for casters on the bottom, and a 45-degree weld would possibly interfere with that. So I've done this before and it seemed to work well. I'm going to try it again. We'll go to the bandsaw and cut these notches out. We'll do some grinding and beveling and cleaning, and I'll weld this up off camera because I'm not showing off my welding for everybody in the world. I'll show my setup and process for drilling and tapping for the casters. Got a chunk of scrap 1x2 cold rolled bar stock to elevate, to leave clearance underneath the piece for the drill. Spotting drill. I believe it was Stefan Gottsvinter did a video discussing center drills and spotting drills. He's not partial to the typical centering drill, except for the very tip. Centering drill typically has a 60-degree included angle, which does not match the angle of a drill bit, typical drill bit. Spotting drills tend to have 90-degree. All the ones I had before were 90-degree. He likes the 120, which is a near perfect match for a standard 118-inch drill bit. So I bought a couple of those, and they seem to work better. They seem to pick up centers. The drill bits seem to pick up the center a little bit better. So I've already done one of these lower pieces. So I've got this set up all figured out. In order to get my drill, or my tap handle in there, I need to run the bed up and down between operations. And we get a little elevation on this. I'm up to get the drill bit. I run the center, the spotting drill down just far enough to act as a countersink for the finished hole. We come out here 9/16, or 15/16, 937.5 on the VRO. And pick up another one. when I'm doing rectangular patterns like this, I like to do across the short leg first, then the long leg, go out to 0 in this case, back to 0, and then you only have to do the long travel one time. The other two directions you're doing the short travel. It saves a little time if you work your pattern around that direction. Back to 0 here. Pick that up. Tap drill number 7 for 1/4 20. And a little dab of lube. I like these tap holders for use in the milling machine on the lathe. Tap handle with a plug. Collet sort of arrangement to go into the drill chuck. And crank it down. This is a taper tap, but it seems to be getting a full thread all the way through the 1/8 inch angle, just as the tip comes against my scrap block. And I just run around the pattern with the tap. I have the stop set for the X here. For the Y, I'm just measuring by eye. This is not critical enough to bother with a center finder and a super accurate measurement. I just wanted in the ballpark of 1/4 inch from the corner in each direction for the starting hole. Oh, now we're all tapped and ready for the casters when the time comes. Finished cleaning this up a little bit, time to do some welding. Well, we have progress to show. Frame is welded up, all holes drilled and tapped. Hardware is laid out. New casters ready to bolt on. Now we'll go for primer and a coat of paint before we finish the assembly. We'll do that off camera. Okay, got the stand welded and cleaned, painted, ready for some casters. Got these in here to stand it off while I turned it over on a flat surface to keep the paint from sticking. I have had on a couple of these stands that I've built, I've had to use extra flat washers under the machine screws to keep the end of the bolt from sticking through here when the whatever stand was going on the dolly had features that would interfere with the screws on the other side. This time I don't have that problem. Now let's see what we're going to put on it. If I measured correctly, this ought to fit. In my younger days, I would have just picked this up and set it down. I'm beyond that now. Well, how about that? Well, there's another little shop organization project finished. Thanks for watching. Here's a problem you need to watch out for. The riveted part of the swivel on the caster that sticks above the base protruded above the base, and as you can see was rubbing on the bottom side of the frame. I took a die grinder and ground off enough of that swiveling button to provide clearance between the button and the bottom of the frame, put it back together, and it worked fine after that. This was a medium quality caster, came from MSC, Manhattan Supply Company, not a Harbor Freight cheapie, so this is a problem could occur with anybody's caster, I suppose. If you can't get the swivel action to work properly, take a look for this. I've only seen this the one time in I don't know, half a dozen of these frames I've built, so it's rare, but it is a problem to watch for. Something else to keep in mind when designing a caster base is the weight distribution of your tool. If it has a high center of gravity or an offset center of gravity, or as in the case of this wood cutting bandsaw, a table that overhangs the base, you might want to consider extending the rails in one direction or another as appropriate to provide a little more support. I've done that on the base for this bandsaw, extended them about 4 inches in the direction of the overhanging table to make it a little bit sturdier. Hope this helps. Thank you.